In last video we did exercise set 3.1 question number 1 to 6 and we solved it using the Rolle's theorem. Now here we are going to solve the remaining questions that are related to the mean value theorem, that are from question number 7 to question number 10. Before going to these questions, we must know that what is actually mean value theorem and what postulates we have to use in calculating the value of C in these questions. So mean value theorem, let f be a function that satisfies the following postulates. The number one postulate is f is continuous on the closed interval ab. Same postulate was in the Rolle's theorem we did earlier. Like f is continuous on the closed interval ab means you have to check any value of the interval. Like f has any discontinuity on any value of this interval, then f will not be continuous. If f is having all the defined values within this interval and including these points a and b, then we say that f is continuous. Then we will move on and we will check that f is differentiable on the open interval or not. For checking this postulate, we have to take the derivative of the function. Take the derivative of f, get f dash of x, and then check on this interval whether it is having all the defined values or not. If f dash of x is undefined on any of the value between this interval, it means f is not differentiable. And we will stop here and we will say that the mean value theorem is not valid. If these two postulates are satisfied, then we will move on to this point and we will calculate the value of C using this formula. And for using this formula, you must have the value of f dash of x. We will use f dash of x and we will put in place of x C and make it equals to f of b. Use the value of b, that is the value of interval, put it into the function and subtract it with function having a in place of x and divide it with b minus a, that are the values of the interval, b minus a, and then make it equals to f dash of c and rearrange the equation and get the value of c. After getting the value of C, we will check its validity. If the value of C lies between this interval, it means this is our value of C. If it is not belonging to this interval, then this is not the value of C. I hope now you got the points at how we are going to solve it, these questions. So the first question, that is question number 7. The function is f of x equals to x cube minus 3x minus 1 and the interval is minus 11 over 7 and 13 over 7. Now you see, this is a polynomial function. As I told you in the previous questions in the previous video, this is a polynomial function and polynomial functions are always continuous everywhere. So we'll say f of x is continuous on this closed interval minus 11 over 7 and 13 over 7. Now calculate the value of derivative f dash of x. X cube has the derivative 3x square, then minus 3x derivative minus 3, then minus 1 has derivative equals to 0. Now again, this is a polynomial function, so this will also be continuous. So we'll say f of x is differentiable. F of x is differentiable on open interval minus 11 over 7 to 13 over 7. Now mean value theorem is valid because the first postulate is satisfied and the second one is also satisfied. Now we will use its formula. Mean value theorem is valid. Now we'll have to use this formula. F dash of C is equals to f of b minus f of a over b minus a. For using this formula, we need some values. We need a, that is equals to, that is the starting point of this interval, minus 11 over 7. B here is 13 over 7. F of B. F of B will be basically use this f of x and put b in place of x here. So it will be this cube minus 3x minus 1. In place of x, use the value of b. That is 13 over 7, 13 over 7 here. We will get, simplify it using your calculators, you will get 3 minus 57 over 343. Now calculate f of a. Use the same f of x and in place of x put the value of a. We will get this cube minus 3x minus 1. Now in place of x use the value of a. Minus 11 over 7 minus 11 over 7. Using your calculators, you will get the value minus 57 over 343. Now we need one more thing, that is f dash of c. Use f dash of x and in place of x use the value of c. So we'll get f dash of x equal, f dash of x was 3x square, now it will become 3c square. 3c square, and then we have minus 3, so minus 3 as it is. Now use all these values in this formula, that is f dash of c is equals to f of b minus f of a over b minus a. I can also rearrange it, like I'm making it a straight line equation so that it will be easier for me to calculate it. F dash of c into b minus a equals f of b minus f of a. Now I will use all this value, this one, f of b, f of a, and f dash of c, this is c, f dash of c, and also b minus a, the value of b minus a. B is 13 over 7 minus a is minus 11 over 7. I will use this value, that is basically 13 over 7 plus 11 over 7, so it will be 24 over 7. I will use all these values in this equation, so I will get f dash of c into b minus a, that is equals to f of b minus f of a. So I will get 3c square minus 3 here, multiply by 24 over 7, that is equals to f of b. F of b was minus 57 over 343 minus f of a is minus 57 over 343. I use the brackets because already I am having minus sign here, so this minus and this minus can be confused with each other, so use the brackets. Now simplify it, I will get 3c square minus 3 into 24 over 7. Here I will get minus 57 over 343 plus 57 over 343. This will be cancelled and this will be equals to 0. Now this 24 by 7 is multiplying with this term, and if I will divide it here, it will be like this, 24 over 7. This term, now cross multiplication, I am moving this constant to this side and I will be left only with 3c square minus 3 equals to 0. This whole bracket is multiplying with this term, it will divide here with 0 and it will make it 0. Now I am dividing the both sides with 3, I will get c square minus 1 equals to 0. So c square is equals to 1, so c is equals to plus minus 1. Now we have to check its validity in this interval, open interval, minus 11 over 7 and 13 over 7. Now you see, if we divide 11 with 7, we will get 1 point something, and if we will divide it here also, we will get 1 point some answer. Like you have to solve it with your calculator and just get an exact value. And we see in this interval plus 1 is also in this interval and minus 1 is also in this interval. Like this value will be here, like for example if we have 1.5, maybe minus 1.52, here we have 1 point, if it is 1.3, and if we have a 1.4. In between this interval we have minus 1 and plus 1 as well. So it means this c plus minus 1 belongs to this open interval and it is a valid value of c. So now move on to the next question, that is question number 8. Question number 8 says f of x equals to square root x minus 2 and on interval 2 to 4. Normally the square roots become undefined when we have a negative value inside the square root. But here we have a positive value when you use all the values into this square root. It becomes a defined answer when we use all the values of this interval into the square root. So f of x is continuous on closed interval 2 to 4. Then calculate the derivative f dash of x, that will be 1 over 2 square root of x minus 2, and we will check its validity here. Now in this interval 2 to 4, open interval, check the validity within open interval. Whatever the value you put here from this interval into this one, the denominator will not become 0 and the function will remain defined. One thing, check the denominator. Second thing, check the square root as well. You can't have a negative value within the square root. So if we will check all the values from this interval into this one, the square root will always be positive. So our function is also differentiable. So f of x is differentiable on this open interval 2 to 4. So mean value theorem is valid. Mean value theorem is valid. Now use f dash of c into b minus a equals to f of b minus f of a. Calculate f dash of c. F dash of c is 1 over 2 under root c minus 2. I just used step-by-step values in the previous question. Now I am directly using the values here. I hope you understand it. Now b minus a. B minus a means b is 4 and a is 2. So it will be 4 minus 2 here. F of b. F of b. What is your f of x? F of x is square root x minus 2. Here if we use f of b, it will be 4 minus 2 square root. And for f of a, it will be a is 2. Use 2 in place of x, so 2 minus 2. So I'm directly using the values here. I got under root 2 minus 0. Now rearrange the values. From here we will get 2. That 2 will be cancelled with this 2. So I will be left with 1 over under root c minus 2 is equals to under root 2. Take the reciprocal. C minus 2 is equals to. If I take the reciprocal, the numerator will become denominator. And here the opposite of every fraction. Take the square on both sides. If we square both sides, I will get 1 c minus 2 equals 1 over 2. So c is equals to 1 over 2 plus 2. So c is equals to 5 over 2. And that belongs to interval 2 to 4. Open interval 2 to 4. Because this 5 divided by 2 will become 2.5. So you see that in this interval 2 to 4, 2.5 is lying here. So this 2.5 belongs to this interval. So this is the value of c.